Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're doing algebraic inverse proportion. So let's start by remembering what direct proportion was, because that's going to be important. Pause the video and double check you can think what that was about. Well, two quantities are said to be directly proportional if one quantity increases at the same rate the other quantity decreases. Okay, so what was inverse proportion? We've also talked about this before. Well, inverse proportion, two quantities are said to be inversely proportional if one quantity increases at the same rate the other quantity decreases. So in the case of direct proportion, if you had two quantities, if you doubled one, right, you must also double the other. But two quantities could be inversely proportional. If you double one, you'd have to half the other, right? And that's basically the difference between the two. And that's going to be important for us. Now, I'll give you an example of an inverse proportion problem we've solved before, something like this. Pause the video and double check you could solve it. So, when you're building a building project, 4 builders, okay, are needed, and it takes them 12 days to do it. Now the question was, how long would it take if you had 12 builders? So if instead you had 12 builders, how long would it take? Well, you've just got to think to yourself, the number of builders and the number of days are inversely proportional. If you multiply your number of builders by 3, you're going to divide the number of days it takes you to do the exact same project by 3, so therefore it would only take you 4 days. And that was how we solved these before. Now we're trying to solve problems like this, but algebraically, because that can be useful for us too. So the exact same problem algebraically might look something like this. The time y days to complete a project is inversely proportional to x, where x denotes the number of builders hired. If y is 12 when x is 4, i.e. if it takes 12 days when the number of builders is 4, find y when x is 12, i.e. find the number of days it would take when your number of builders is now 12. So that's the exact same problem, and we're trying to solve these algebraically. Now don't forget, we could always solve these ways, that's absolutely fine, but algebraically is going to be useful in complicated cases. So I've got to show you another way of doing that with x's and y's and things like that. So one more idea to demonstrate before I show you how to do these questions, and it's the following. Suppose we had the scenario that y is inversely proportional to x. Remember, that means that if we increase y, we must decrease x by the same rate. And we're also told that when y is 1, x is 0.5. Now I want to keep a track of the values for y, values for x, and values for 1 over x, and it will become clear soon why I'm doing that. So let's put the first value in. Let's put y is 1. We know at the same time y is 1, x is 0.5, and we also know that 1 over x is 1 over 0.5, like that, and 1 over 0.5 is 2, isn't it? 1 divided by a half. Now imagine I doubled the y number, so I'm going to double the y number to be 2. What must I do to the x number? Well, because y and x are inversely proportional, they must obey a relationship. If that one doubles, this one must half. So half of 0.5 is 0.25, or a quarter. So 1 over x must be 1 over 0.25, 1 over a quarter, which is 4. Alright, and let's do one more. Why don't I, so I'm just going to show a picture of that. I'm going to say that was times by 2, and I'm going to say that was obviously divided by 2. And I'm going to do one more. So say I did one more here. Say this one here, I didn't times by 2. Let's say I multiplied by 5. So 1 multiplied by 5 is 5. What must I do to the x number? Well, I must divide this by 5, mustn't I? So I'm going to divide by 5 here to get 0.1. And I'm just going to work out x, which is 1 divided by 0.1. And 1 divided by a tenth is 10. Now, there's something I want you to notice here, and hopefully you can spot it. As I doubled y, I divided x by 2. That's because they're inversely proportional. As I multiplied y by 5, I divided x by 5, again because they're inversely proportional. But look what happens to 1 over x column. Look, as I multiplied y by 2, watch what happened to the 1 over x values. They doubled. As I multiplied y by 5, what happened to the 1 over x values? They got multiplied by 5 as well. So we've encountered something really useful to us. In fact, if I know that y and x are inversely proportional, to each other, then it seems to me that y and 1 over x are directly proportional to each other. If I double y, I double 1 over x. If I multiply y by 5, I multiply 1 over x value by 5 as well. And that's exactly the idea we're going to use, and here it is. Y is inversely proportional to x means exactly the same thing as y is directly proportional to 1 over x, the reciprocal of x. Alright, so that's really important idea. It's going to be what gets us through the following questions. If you see two values are inversely proportional to each other, say for example someone told you, I don't know, C was inversely proportional to D, you know that C must be directly proportional to 1 over D. Alright, so key thing, y is inversely proportional to x means the same thing as y is directly proportional to 1 over x, and that's what we're going to use. So let's go ahead and try these questions. Pause, have a go. Right, we are told y is inversely proportional to x. That means y is directly proportional to 1 over x. We translate this line here into this first statement here. And once we've got that first statement, we can proceed with the normal algebra. Therefore, we know y is equal to k multiplied by this, which would be k over x. Then we substitute y as 10 and x is 2 in, so we would say that 10 is therefore equal to k over 2, and that tells us therefore that k must be 2 multiplied by 10, which is 20. Then we must go ahead and write our formula down. Y is therefore equal, not k over x, but 20 over x, and that is our formula for y in terms of x. Having got that, we can answer any questions thrown at us. Find y when x is equal to 5. We can just substitute in 5 here. Y is therefore equal to 20 over x, where x is 5, so 20 over 5, and y is therefore simply 4. Next one, we're finding x when y is 6, so substituting in here for y is 6. 6 is therefore 20 over x. So multiplying by x and dividing by 6, I can say that x is therefore 20 divided by 6, and 20 divided by 6 could be simplified to 10 over 3. It's absolutely fine to leave your answer as an improper fraction, and we're done. Next one, pause the video, have a go. S is inversely proportional to t, translate that to s is directly proportional to 1 over t. Then you can say that s is therefore equal to k over t. We can substitute in here, 0.8 is therefore equal to k over 4, and so k must be 0.8 multiplied by 4, which is 3.2. We can then state our formula that s is therefore k, which we found is 3.2 divided by t. Now we can use that formula. Find s when t is 0.2. S is therefore equal to 3.2 divided by 0.2. We can multiply top and bottom by 10 to get the equivalent fraction, 32 over 2, and we know that the answer to that would be 16. Find t when s is 4, so we can state therefore that 4 is going to be equal to 3.2 over t using this formula. So t is therefore 3.2 divided by 4, which we can type into our calculator, and typing that into our calculator we get that t is therefore equal to 0.8, and we're done. Next one, pause the video, have a go. Now here, f is inversely proportional to d squared, so f is directly proportional to 1 over d squared. Therefore f must equal k over d squared. Substituting f is 18 and d is 2 in here, we get 18 is k over 2 squared, which is 4. So this is 4, so k must be equal to 18 multiplied by 4. If you do 18 multiplied by 4, you get 72. And restating your formula, f is therefore equal to 72 over d squared. Now we can use that formula, find f when d is 6. We can say therefore that f is equal to 72 over 6 squared. 6 squared is 36, so 72 divided by 36 is simply 2, and we're done. We're supposed to find d, the positive value of d when f is 12, so we can say therefore that 12 is equal to 72 over d squared. Rearranging, we get d squared is equal to 72 divided by 12. 72 divided by 12 is going to equal 6. So d squared is going to equal 6. So taking square roots, we get the positive value of d is therefore the square root of 6, and we're done. Next one, pause the video, have a go. Right, f is inversely proportional to root g, so f is therefore directly proportional to 1 divided by root g. Therefore f is equal to k divided by root g. Substituting in, 10 is therefore equal to k divided by root 9. Root 9 is 3. K must therefore be 10 multiplied by 3, which is 30. Rewriting this, we get f is therefore 30 over root g, and we're done. Now we can use that formula. Find f here. We're going to substitute in 20 over 30 divided by root 25. Root 25 is 5, so f is therefore 30 divided by 5, which is 6. The other way around, we substitute in 15 for f, and we have that as 30 over root g. Rearranging, root g must be therefore equal to 30 divided by 15, which is 2. So root g is equal to 2. And squaring both sides, we get g is 4, and we're done. And that's it for this particular video. Thanks for watching.